Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing on with techniques and applications for definite integration. Over here, we have another example for the definite integration, whereas we have to find the volume removed when a hole of radius a is bored through a sphere of radius 2a, the axis of the hole being a diameter of the sphere. So over here we have this sphere over here, right? So for this part we have a hole of radius a, basically the radius of the cylinder, and these two caps, and these two and this whole cylinder and these two caps were removed from the sphere, whereas the radius of the sphere is 2a instead of a. So for this part, what we have over here is that we just have to find the volume that is removed. Basically, we just have to find the volume of the cylinder and the two caps. So first of all, what do we have here? So we need to find what the small h is, right? Because for this part, the small h for over here, we will need to use it to find the caps, while on the other hand, for the cylinder, you also need to know about the small h. Well, for this part, the cylinder, I'm going to do it later and find its volume later. Because over here it basically just pi r square then times the capital H. While the two caps first, but before I find either of them, I'll have to know what H is equals to, right? But how am I supposed to know what H is equals to? So here we are going to revise on what we have learned in the past, which in this case will be the intercepting chords theorem, whereas we have this green circle over here and you see these two chords intercepting, right? And the two chords are DEC and AEB. So for this part, what we'll have here is, apparently for this, the theorem is basically AE times BE is equals to CE times DE. Over here, the which one you put first doesn't actually matter, okay? So for this part, what we're going to have here is going to be, so since we gotten that, so you can tell that one of the chords over here can be the diameter of the cylinder, which is basically A. So this is one of them. So if you look at it like this, like you straight up look at it like this, it's basically just like a circle, whereas one of it will be this part, the diameter of the cylinder, while the other one will be the whole diameter of the sphere. So the two chords intercepting will be here, over here, and the diameter of the cylinder and the diameter of the sphere, which will be, so the diameter of the cylinder is basically 2a, right? So for this part, it basically this times this, because of, so this is basically the point of interception. So what we're going to have here is a square. So what is a square equals to? So a square is equals to this part times this part. Basically this whole length over here. Basically capital H minus small h, whereas it will be, so here you have h times, so what is capital H basically? So capital H over here, capital H plus the small h is basically, the 2 of the small h is basically the diameter of the sphere, right, which is 4a. So 4a, hey, so if you're only considering this part, it'll be 4a minus the h above. So it'll be, so what we'll get here, 4a minus h. And then after that, if you times this in, what you have will be h squared. So you have 4ah So if you move this here, you realize that this will become h squared minus 4ah plus a squared equals to 0. And now we use the quadratic formula, whereas we can find what h is. So h basically being, so h by using the quadratic formula, whereas we should get negative b plus minus square root b squared minus 4ac over 2, a over here we'll have negative b, whereas for this negative for a, once you negative again, it becomes positive. So here you have for a, then you plus minus square root b squared minus 4ac, whereas the b here square, once it squares, the negative will get cancelled and it will become 16a squared. Then here you minus 4ac, whereas the a is 1. And the c over here will be a squared, so 4a squared over her 2a, which we'll get just over 2, okay? And if we calculate it over here, what we're going to get for this part is 4a plus minus square root 3 to 2 square root 3a. So 2, because you can take out 4 for both of these, so here you get 2, and then you have the 4 minus 1 being 3, and then here you can also take out the a squared, which you're going to be left with the a. And here now both of these parts can be divided by 2, so we will divide them by 2, and you'll get 2a plus minus square root 3a. So you have two choices. One is for 2a plus square root 3a or 2a minus square root 3a. But hold on a second. I do not care how flat the cylinder may be, but if you add 3a, that means that the height over here is even longer than the radius, which means that it would not be able to exist, because that this part over here, it's impossible for the height, the small h, to be bigger than the radius. Or else how are you supposed to get a radius and all? So over here, our height is most definitely 2 minus square root 3a. Well, it's actually pretty obvious, because you'll be able to figure out that the height must not be bigger than the radius itself. So now that we have figured out what a is, we can find out the volume of the cap and all, right? But wait, what's the volume of the cap? So if you look at this diagram, it gives us a visual representation of what it's basically like. So just to be accurate, so for this R is basically A, while for this R over here is basically this part, okay? So over here, so how do we find the volume of the cap? And in fact, I'm going to times 2 straight away, because we have 2 of them, and which we have to, because this is basically, because we are calculating the cylinder later, well, these 2 are also going to be removed. Well, what is the volume of a... So the volume of the cap is basically... So when I write this, it's basically according to this circle with this dotted outline over here, okay? it'll basically be like this. So this is the formula, okay? So now that we have gotten this part, so for this what we have is basically 2 over 3. Then pi, so what's our h over here? We've already got our h, which is 2 minus square root 3. A, well, the reason why we can put a over here is because that this variable over here, this is basically already a constant instead of a variable, because that is pretty much written in the question over here, whereas on the other hand for h we just assume it. Okay, so for this part you need square for, here we have h squared, then we have 3r minus. So what is this r? So as I told you, it's like this, right? So it goes from the center to this part, which means that it is the radius of the sphere. So the radius of the sphere being 2a, so here you get 6a minus 2 minus square root 3a. And this is what you get. So here, this part stays the same part. Well, for this part, what you're going to get here is, so when you square, you realize that for this part, you have 4 and you have 3 over here, which are going to add together 7. Then here, you're going to have these two times together, then times 2, which minus 4 square root 3. A square, and here you have, so you can basically take out another a. So for this part, you're going to get like this, okay? Alright, so now that we have gotten this part, what we are going to get here is, so you can times these two together, right? Which you're going to end up with so give me a second. So for this part, it's basically this over here times this, which will get 28, then plus 7 square root 3, then after that here you minus 16 square root 3, and then after that you minus 12 over here, which you're going to end up, and then here you're going to end up with, so these two you minus, you get 16, so 16, and then after that these two you minus, you're going to get at negative 9 square root 3. A cube, okay? So over here you, well, that'll be for the cap, for the volume of the cap. While over here, now we can move to the volume of the cylinder. So the volume of the cylinder is basically, so the volume of the cylinder is basically the circle times the height, right, which are going to end up with, so over here, what's the capital H? The capital H is basically the whole diameter minus the two heights. It means that you're going to minus 2h instead of 1. So here you're going to get, so pi r square. So the pi r square, the pi r is basically a, the small a in this case, because we're talking about this r. So pi a squared times the height being 4a minus, so diameter minus the two heights minus 2 minus square root 3a, like this, okay? So here you're going to get 4, so this part, if you times it and you realize this is 4 minus 2 square root 3, whereas these two will cancel each other out, and you'll realize that this is just a 2 square root 3 pi a cube. Okay, so for this part, 2 square root 3 pi a cube. Now that we have found out both of these, we can find the total volume. So the total volume is basically these two add together. So when you add these two together, you're going to end up with So now what we're going to have here is basically So for this part, when you divide it by 3, you're going to get 3 square root 3, which you're going to end up with a 6 square root 3, which you will have to, this is a negative 6 square root 3, so we'll put it with this. It's going to be a negative 4 square root 3, and then pi a cube. And there we have it, our result. So this is our result for this example, where we have to basically find the volume for the cylinder and the two caps. Whereas for and in order to find both of these, we had to find the small height, either to find the height of the cylinder or just to straight up find the volume of the cap. And to find it, we used the quadratic formula. Well, over here, the volume of the cap, we basically use this formula. And for the cylinder, we basically use the circle and times the height. And to find the height other than using the quadratic formula, before that, the first step over here, we referenced it back to the cos-intercept theorem. Okay, so that'll be all for this lesson. So and thank you for your watching.